Yeah, so yeah, here we go. Thank you, Ryan, for giving the extended tutorial about Zarr. And so this is basically a two-part talk. So I would be giving an overview talk about what Zarr is and how things are done over in Zarr. And Ryan would be taking care of the cloud part, like cloud native part of the Zarr. So let's start. A little bit about me. I am the community manager for Zarr. I have just started the position, and before that, I was heavily involved with PyData, and I'm also taking care of PyData Delhi, and also chaired a couple of PyData conferences. And I worked with startups, forensics, and organization in the past. And when I'm not doing anything on my computer, I tend to play violin. And if you like this talk, you can follow me on Twitter or just give a cheers and thumbs up. So this is what I'm about to show you, like what is Zarr and how Zarr works, why use Zarr, and what is Zarr specification, and the implementations. Like there are like various implementations of Zarr in different languages, and how does Zarr basically ties up with PyData ecosystem, like all the other libraries like Xarray, Dask, and everything that you've seen in the tutorial, and what is basically the Zarr community, and where are future goals, and last but not the least, geospatial data in Zarr. So yeah, Zarr was basically created by Alistair. Alistair is Oxford genetist, and it was founded back in 2015. And he was basically looking at data format at the time to to work with quite large data sets that could read and write across multiple threads and support parallelism. And it was like nothing, that was basically solves this problem. So he went on and created Zarr. And Zarr is basically industry ready, and people are using it into production a lot. And currently it has 21 core devs, and we are fiscally sponsored by NumFocus. So yeah, all our legal operations and everything is taken care by NumFocus. And we have also been funded by CZI. CZI is basically Chan Zuckerberg initiative to support essential open source software. And yeah, you can follow us on Twitter and GitHub, and or this is our website zarr.dev. So all of the updates and everything basically goes around these channels. And we recently also got a LinkedIn LinkedIn profile. So if you're on LinkedIn, you can also follow that. So yeah, so we basically missed like a couple of plottings in the notebook, but yeah, here's what different kind of images, different kind of data looks in Zarr. So the left side is the oceanography data format, which is basically for the geospatial environment, and on the right side you can see the image from the microscopy environment. So I'm not really sure what it is, but yeah, it looks beautiful. So yeah. So yeah, before Zarr, let's have a look like what an array or tensor is. So I just want to start from the ground up and address audience of all the levels. So yeah. Basically array or a tensor is a container of items. So array could be like a single dimension, two dimension, or multiple dimensions. And all the containers of the items are of same data type and size in bits. So if there's an 8-bit, there's an 16-bit, 32-bit, 64 bits, and so on and on. And the number of dimensions and the items in the container are described by the shape. So if you define the shape as a single digit, then it's going to be a single dimension. If you go with 2D, it's going to be like 2 dimensions, and 3D, and so on and on. So yeah, like what is Zarr basically? So Zarr is like an open source specification format for storing chunked, compressed, and n-dimensional array. And when I say specification, I would emphasize on that, and I would explain later like what does a specification means basically. So yeah, basically how does Zarr work? So let's just say you have a small array and small data you want to store, and you can easily store it on your memory or on your disk. Like, but what if the data is too big to fit in a memory? Like, I don't know, maybe around 100 million or 1,000 rows or something like that. How would you fit that? So what basically Zarr does is like it divides your array into small chunks, into evenly distributed chunks. and then each chunk is basically compressed using a wide range of prominent compressors. Like we by default we use BLOS, but there are all other compressors that are prominent, like ZST, zlib, and they're all available in a numcodex library. So you can just go over to this link and you can see the available compressors, and you can just as you would create your Zarr array using Zarr store, you can just specify your compressor over there. And only the chunks which corresponds to your selection desire are being read back into memory. So you need to basically specify like which chunk you want to read back into memory, and only those will be read back, and all of the other chunks would be stored into memory. So it will not take your disk space. And yeah, so multiple arrays are basically organized into hierarchies of groups. So it's like Z arrays. And so the green part, which you can see on your screen, is basically the metadata, which contains the format, and which contains the information about the data. And the purple or pink, whatever color it is, it's the data in binary format. And .z array basically describes how those binary blobs are encoded, and each binary blob is basically given a unique key, and they are basically referenced using that key. So you can see that there's 0.0, 0.0, 1.0, 0.1, 1.1, and so on and on like that. And so yeah, how does the basically the whole compression thing happens in Zarr, and how does everything happen? So you basically take those so Zarr basically take those contiguous binary chunks and pass it through any optional compressor you can find in the numcodex library, and that gives basically a sequence of bytes, which you can see right here, which is basically 011110. And that sequence of byte is basically gets stored as a mapping with the key, which is basically 0.1 for the image and for the depiction in the image. And so conceptually, all the storage is basically happening is like a key value store, and where key are basically strings and values are basically sequence of bytes. And any system which can expose the key value system type interface, they can use Zarr store. So that's the I would say the interoperability, or the diversity, or like how Zarr works. And so for the Python implementation, we basically use mutable mapping to interface to set and retrieve Zarr data. So basically set item to set keys and get item to get the keys and its value. Yeah, and so there was one thing that Ryan mentioned in his tutorial about writing concurrent data to your different chunks. And so I'm sure like a couple of you might have thought about, like, is there a write lock which could happen during Zarr? So yeah, so if each writer is writing to a different region of an array, and all the writes are basically aligned with the different chunk boundaries and not overlapping each other, then writing lock would not happen. But if writers are not aligned with the chunk boundaries, with the different chunk boundaries, then the write locks could happen. So this is just a very small thing you can keep as a footnote while you are concurrently writing data to your Zarr in a cloud format or in a local storage. So yeah. Yeah, so as you can see in the tutorial, and as you have seen in the my explanation, like why use Zarr, like there are different formats out there. So yeah, the first and the foremost important thing is like arrays can be read and written concurrently from multiple threads and processes, and that basically gives a edge to Zarr, and you can basically speed up your operations and your workflows like many times. And it's like very easy to append and extend and append data to your Zarr store. And you just saw that how we did that in using the S3 bucket and just writing data to it. And you can chunk arrays along any dimensions, like you can chunk arrays along so if you define 3 dimensions in your 3-dimension data, you can chunk array along any dimension. So it's not restricted to any dimension, like 1 dimension. And as I've also mentioned earlier, like there's an extensive support for compression. So we are basically always in pursuit of like adding new compressions to our numcodex library, but there's also a list of like a large list of compressions, so you can choose any compression according to your use. And so as I've said earlier, that any key values interface system can use Zarr store. So it basically supports both the local and cloud storage system. And about the specific, and so yeah, it's basically based on a specification, and which allows it to be hackable. And I would be talking a bit about specification in the next slides. Yeah, so what is basically Zarr specification? So Zarr specification is kind of like a technical specification or a set of rules or protocol which are basically written, which are basically used for storing Zarr arrays. And we basically use current version 2 right now. And it is basically us you can, so if you follow the specification, and you can write the implementation of Zarr in any language. And there have been a lot of development recently in different languages like C++, C, Julia, JavaScript, and all of that. So specification is kind of something, I would say, like a Bible for Zarr when you are basically writing the implementations. And it basically tells you how the hierarchies are organized and arrays are chunked and grouped, and how the metadata should look like. And so V2 has been going on for some time, and we are basically kicked off the development of V3. And there's a PR number 898 on the Zarr Python. I would share the slide so you can just look at the PR, and it's currently in the progress, and we basically hope to see that happening very soon. Yeah, as for the implementations, I have mentioned earlier, like we have the Python implementation, which is the most prominent and most used, and but we also have like Unidata folks have developed Java and C++ implementations, which you can find under their GitHub repositories, and C++ implementation, Julia, and JavaScript. And it's like I mentioned earlier, like if you follow the if you read the Zarr specification protocol, it's relatively easy to implement Zarr from scratch. Like if you have I'm not sure if there's implementation in Fortran or any low level languages, but if you want to do that, you can definitely do that. And I'm sure there would be a massive increase in your write and read time speeds using some low level languages. So yeah, I would talk about the Zarr community and future, and after that, Ryan would emphasis on the cloud importance of Zarr. So yeah, what is Zarr community and how you can join us? So Zarr community is essentially the users, the developers, or anyone who is interested in Zarr and wants to contribute to Zarr. And it's like an open community, and everyone can just start contributing to it. And if you're interested in Zarr in any way, you can just join us. And there is like no hard and fast rules to join Zarr. You can just head over to our Gitter channel and just drop a message to I'm interested in Zarr and I want to I want to contribute in the development, and I'm more than happy to point you to some issues. Or if you're basically using Zarr and you want to I don't know, maybe get some help, like get some helps or get to know some tips and tricks from the users or the community, yeah, just drop into our Gitter channel, and I'll be more than happy to direct you over them. So this is what Zarr community is, and let me talk a bit about future. So since I've joined the Zarr, I have been working on the ZEP. So ZEP is basically ZEP stands for Zarr Enhancement Proposal. The naming is quite similar to the Numpy proposal, which is NEP, and Python Enhancement Proposal PEP. And which is basically a community process to implement changes to the Zarr spec. And it's something like a structured way or a process to include the changes in the spec. So previously we used to do like used to follow the GitHub workflow to include changes, but now we are basically finalizing the ZEP. The discussion has been going on for like a month, like quite a month, and we are basically in the stages of like final confirmation for the ZEP. And if there are any changes that needed to be added to Zarr, or more importantly the Zarr spec, it would follow the ZEP protocol or the ZEP process. And if I talk about like V3, like what does V3 look like and what are the features? So like in terms of spec, the bigger change the V3 is moving towards is like separating the metadata from the file structure and the arrays. And also we have ask around community and take a community consensus in effect, and seems like everyone in the community wants to have that, like separating the metadata from the main data. And there's a very interesting I would say spec change that we are looking for is like a extension protocol. So currently the spec doesn't allow you to have extension protocols. Currently the spec currently the spec only has the core protocol. So if there are any changes that are done into the spec, that needs to be implemented over all the other implementations of Zarr. But we are basically looking towards an idea of having a protocol extension, which would basically allows you to have a optional change in Zarr, which could be used by other implementations or implementation which you will develop by you or not. So it's kind of like a mechanism which basically gives Zarr a very personalized feel. So if you're working with Zarr and you want to have like a small support for some variable or some feature or something like that, and you're not sure that it should be in the main core protocol, you could add it as an extension protocol and it would work, and you don't basically need to follow the zip process or all the community process for the extension protocol. So this is what the v3 v3 in general looks like, and it's still in development. So if you have any, I would say, suggestions or some recommendations for us, so feel free to join our Gitter and drop us suggestions over there. We are more than happy to take them away. And the most interesting thing that we are working on right now is the sharding support. So I'm not gonna go deep into sharding, but you can see this PR and there's a lot of discussion about that. So yeah, this is what the future of Zarr looks like, and the community is great, and a lot of things are happening. Like sharding and v3 are basically the main thing, but also we are having a zep to basically cover everything which has been going into Zarr community, and it's like a very wonderful time to join Zarr and get involved in the developments and give us suggestions and stuff. So yeah, seems like Brian, would you like to?
We're out of time, so I'll just go real quick. Zarr is often used in the geospatial context as part of this sort of Pangeo cloud-native software stack that interoperates with Dask and Xarray. And this software stack, allows us to take advantage of cloud object storage on every cloud provider. It allows us to scale out using Kubernetes or other distributed computing low-level primitives that are provided by the clouds. And for geospatial data, most end users are really interacting with Zarr through Xarray, as I showed in my tutorial. That allows us to then have a lot of domain-specific packages on top of that really can just focus on one specific application rather than having to reinvent sort of I/O and the core data model. And of course, using Jupyter Lab is a very common way to interact with those tools in the cloud. Next slide. So as for geospatial data in Zarr, basically, if you take Zarr and then you store the netcdf data model in it with CF conventions, you have a cloud-native geospatial data format. And that's what we've done sort of to get things started. Zarr v2 is currently up for vote as an OGC community standard. And the community standard really just covers the actual core Zarr v2 spec. Doesn't address geospatial data. There is another spec that is it's sort of a set of conventions on top of the core Zarr spec called Geozar, which have been proposed by Christophe Noël of Spacespell. And right now, I believe that is also working its way through OGC as a more formalized way to encode geo-specific information like CRS, labeled dimensions, etc., within Zarr. And so this is certainly a place where alignment is needed. Yeah, and I mentioned the Pangeo stack. So next slide. So I know this is a big topic, Zarr versus Cog, when to use each. This is my attempt to lay this out. So Cog is really limited to 2 dimensions plus bands. It really comes from the GIS raster data model. It's great for satellite imagery with a single scene per cog. And it really needs stack to extend to, you know, higher dimensions, time series, data cubes, stuff like that. Zarr, in contrast, is n-dimensional. You can store any number of dimensions in it. Could you please go back?
Yeah, sorry.
For geospatial, we're really using the netcdf data model. Zarr is great for L3 and above satellite data, stuff that's been gridded, harmonized data cubes, simulation data that's run on a fixed grid. And because of its ability to incorporate so many dimensions, it doesn't strictly need stack in order to store a very large, complex, you know, data structure. However, we would like Zarr to integrate better with stack so that we can expose Zarr data through stack. Next slide. These are two examples of Zarr datasets in the cloud. These are also in the tutorial. One is the CMIP6 public dataset that's in AWS and Google Cloud Storage. It's over a petabyte of data, split up into 500,000 individual Zarr stores. In contrast, we have the MER sea surface temperature dataset that was produced by Amy and Shell Gentleman. And this is a level 4 sea surface temperature product. It's 54 terabytes in total, and the entire thing is one big Zarr store. So that's a sort of two very different ways to sort of organize Zarr data in the cloud. Next slide, and I think that's the end. Yeah, so that's where you can learn more. We really welcome everyone's input. We're working hard on the V3 spec and would love to engage the OGC community there. And sorry for going long.
Yeah, and just a small note, we have our community call tonight for me and evening for European folks. So if you have any time, or if you feel like joining our community meetings today, you can join us. It's on our web. You can find the link on our website. And yeah, everyone is welcome.